Okay, today we're going to take a look at polynomials. Polynomials are just several terms, meaning one or more terms that are added or subtracted together. And you might have exponents on your variables, and those exponents on your variables have to be 0 or natural numbers, meaning positive whole numbers, no decimals, no fractional exponents, and no variables in the denominator. So, looking at this problem, it is a polynomial. There's several terms that you need to be familiar with. The constant, we have three terms up here. The three terms are the three things that are added or subtracted together. The constant term is the one that doesn't change based on any variables. Well, that would be your 2 because it has no variables. Your variable would be your x. You can put any number you want in for x. Now, also we have coefficients. Coefficients are the numbers in front of your variables. So that would be your -7 and also your 5. And then your degree is the highest exponent that shows up here, which happens to be 3. So your degree is 3. Now, your leading coefficient is the coefficient, meaning the number in front of your variable, with the highest power. So here's your highest power. So your leading coefficient would be 5. So we want to look at these down below here. Are these polynomials? Yes or no? Now, this first one is not a polynomial. Yes, you have several terms added or subtracted together, and you have positive exponents on the variable, but you have a variable in the bottom, so it does not work. When you look at the next one, it is not a polynomial because your exponents on the variables have to be positive whole numbers, and we have a fractional exponent here. If you had a fractional exponent on one of your coefficients, meaning once again those numbers in front, it would not make a difference. It has to be positive whole numbers only on those variables for your exponents. Now, this next one is also not a polynomial. Yes, you don't have variables in the bottom, and you might think you have positive whole number exponents, but this first one has a variable in a root. A variable in a root is really a fractional exponent like what we have right here. So the cube root of x squared is really x to the 2/3 power. So once again, we have a fractional exponent. So it does not work. This last one over here is a polynomial. You might be thinking, yes, we have a root, but it's only our coefficient or a number in our root. That root does not apply to one of your variables. All the exponents on your variables are positive whole numbers, and you don't have any variables in the denominator. So here we have two terms added together. When you have two terms added together, we call that a binomial. Three terms added together, we call that a trinomial. Now, a lot of the directions you'll be coming across will be saying simplify. Simplify means eliminate all parentheses and combine any like terms. So here we need to simplify. We need to get rid of our parentheses while the parentheses around the beginning are doing nothing. But to get rid of the parentheses here, because there's a subtraction sign, we have to distribute through that subtraction sign to each number after that, or term after that. Now we can combine together our like terms. We have 2a cubes minus 1 of the a cubes gives us just an a cubed. Then we have 5 of the a's plus 3 more of the a's gives us 8 of the a's. Then we have a -7 and a -2, which gives us a -9. Do this next one quickly, and then watch the video. So once again, the first parentheses aren't doing anything. You distribute through, combine your like terms. Your 3x squared minus 4x squared is -1x squared. Your 2x minus an x is only one of the x's, and then a -3 plus 5 is a +2. So here you have one thing in front times everything in the parentheses, so distribute that through, and -y times a 4x squared is a -4x cubed. Distribute that -y onto your 2y, and that gives you a -2y squared. Negative y onto your negative 3 would be a positive 3y. Oh, well, this isn't right. Oops. Sorry. Just a second. Oh, that looks a little bit better. Here we have two terms times two terms, meaning a binomial times a binomial. So to work that out, we need to refer to what a lot of people say is FOIL. You multiply the first terms together. 2p times 4p is 8p squared. Then we do the outer terms. 2p times the 1, positive 2p. Then we do the inner terms. 3 times 4p, that's 12p. Then we do the last terms, positive 3 times positive 1, and then that's positive 3. Now, you'll notice we're not quite done. We did get rid of the parentheses, but we got to combine like terms. Our like terms need to have the same variables with the same exponents. So these two center ones are like terms. None of them else have squared, so then nothing goes with that purple. We add together to the two center ones. 2 of the p's plus 12 of the p's is 14 of the p's, and then we bring down our constant of that plus 3. So quickly go ahead and try to do these here. You might be maybe confused by this first one, but it's a trinomial times a binomial. So you got to take each term in the first one times each one in the second one. So a squared times the a squared times the 2. Then you got to take that 3a times each one in the second one. So 3a times a, 3a times the 2. And then you got to take that negative 4 times the a and then negative 4 times the 2. And then combine together like terms. Like terms happen to be the squared, so we'll bring down our cube. 2 of the a squareds plus 3 more of the a squareds is a total of 5 of those a squareds. And then you have 6 of the a's minus 4 of the a's, leaving you only with 2 of the a's. Bring down just your constant of negative 8. Here, distribute through. Negative x times your next term is this, negative x times that last term. No like terms, you have all your variables or terms have different exponents, so that's it. So here you're going to FOIL first terms, outer terms, inner terms, last terms. Combine together your like terms, the middle two. 3 of the x's plus 10 of the x's gives you 13 of those x's. Just bring down your other terms. Over here, 3 terms, trinomial times 2 terms of binomial. So take that x squared times each one in the second, x squared times x squared times 4. Then take your 3x times each one, 3x times x, 3x times 4. Then take that negative 2 times each one, negative 2 times x, negative 2 times 4. Combined together in like terms, you have no other cubes, so you bring that down. You have 4 of the squared x squareds here, plus 3 more of the x squareds is 7 of the x squareds. Then you have 12 of the x's minus 2 of the x's, and then bring down your 8. And we have a polar bear in a blizzard.